Good morning, girls. How are you? I hope you are all doing fine. Okay, today we are starting in our last lesson in module 17, and we are we are not taking dilation in this module. Dilation will be taking maybe the next module. Okay, today we are talking about something called symmetry. We are investigating symmetry. We are in page, by the way, page 871, page 871. Okay. What is symmetry? You understand what is a symmetry? How do you determine whether a figure has line symmetry or rotational symmetry? This is our essential question today. Okay, what is a symmetry? When I tell you that two things are similar, similar means what? Similar means equal or like each other, similar to each other. Symmetry means that when you have an object that can be divided into two equal parts, this is called a symmetry. A figure has symmetry if a rigid motion exists that maps the figure onto itself. A figure has line symmetry. What is the line symmetry? Before symmetry, we understand that symmetry means equal, similar, very equal parts. Symmetry, girls, have two kinds. We are going to be investigating symmetry in two kinds. You are going to be asked in exams or whatever a question about a figure. He will give you a figure, and you are going to be required to tell him, does this have a line symmetry or does this have a rotational symmetry? But the first thing that you need to understand that symmetry that we are going to be investigating today are two kinds. We are going to be investigating two kinds. The first one is called line, or some books and some websites call it reflection symmetry. It is the same, line or reflection symmetry. And the second kind is called rotational symmetry. So again, symmetry means when your object is like each other. It can be divided or it can be mapped into itself. For example, when you do a translation, the image and your pre-image, are similar to each other. It is the same shape. The image and the pre-image are the same shape. These are called similar figures. Okay, the symmetry that we are going to be dealing with today, as we said, are two kinds. The first one is coming from reflection. As you know, reflection is a rigid or a non-rigid motion. It's a rigid motion. So it can give you a symmetrical shape. We will see how. But this is the first kind, line or reflection symmetry. The second kind is called rotational symmetry. Okay, let's go back to our book. Okay, can you see this triangle? The line of symmetry or the line symmetry, if a reflection maps the figure onto itself. Each of these lines of reflection is called a line of symmetry. You remember the reflection line? You remember when we did reflection together? It was the easiest lesson. What is a reflection? A reflection is, for example, when I have my X and Y, and for example, I have a figure in here, and I tell you reflected across X-axis, it will be in here. Or reflect across Y-axis, it will be in here, right? Of course, it should be the same size. This is called line of reflection. This is called line of reflection. Let me ask you, what, for example, if my figure was exactly in the middle, in here, for example, and I tell you to reflect it across Y-axis. You remember that this is Y-axis. Reflect it across Y-axis. What will happen to your figure? What will be your image? For example, that this is a rectangle, and the Y-axis is exactly in the middle of the rectangle. And I'm telling you to reflect it across Y-axis. What will happen? Actually, what will happen is that my figure will be the same. The figure will be the same. Nothing will happen because this half, the Y-axis, is exactly in the middle of my figure. It's exactly dividing it into two equal halves. So if I reflect this half in here and this half in there, what will happen? The figure will remain the same. So I can say that this figure has a reflection symmetry. A reflection symmetry means that if you reflect your figure across a certain line, it will be the same. This is called a reflection symmetry. And the line that you are going to be doing this reflection across is called the line of symmetry. It's called the line of symmetry, like in here. We have a triangle in here. Can you see this triangle? What if, for example, can you see the paper? What if I fold the paper into two equal halves? Let's fold the paper into exactly two equal halves. What will happen? What do you think will happen? You will find that half of the figure is exactly like half of the figure. Yani if I reflect my figure across the line exactly in the middle, my triangle will be divided into exactly two equal halves. So I will ask you, so is my triangle have a line symmetry or have a reflection symmetry? Yes, it has. Why? Because there is a line that exists that if I reflect my triangle across it, it will give me the same shape. This is the line. If I reflect my line, if I reflect my figure across this line, it will give me the same shape because it's dividing the two parts into, dividing my triangle into exactly two equal halves. So let me ask you, can you try to think in this triangle about any other line that can divide your triangle into two equal halves? Okay, so we understood that we have a line of symmetry in here that exactly pass in between, in the middle. This is a line of symmetry because it's dividing my triangle into two equal halves. Let's try. Can we think about another one? For example, if we passed a line in between in here, and just to understand well. Yes, in here. For example, what if we draw a line, the line of symmetry is in between. What if we draw another line from here? Think, is this a line of symmetry? Does it divide your line, your triangle into exactly two equal halves? Is this part equal to this part? What do you think? No, right? At all. It's not a line of symmetry. It's not a line of symmetry. So this is not a line of symmetry. Now, let me take another line. Let me take another line. What about the other part? What we have if we have a line from here? Ask yourself, is this a line of symmetry? Does it divide your triangle into exactly two equal halves? Again, no, right? But again, this is not a line of symmetry. Okay, so what if I have a line in here? Is this exactly two equal halves? Again, no. So actually, this triangle have only what? Have only one line of symmetry. So you are going to draw this line of symmetry because each time he will give you a figure, you are going to be required to graph or to draw the line of symmetry. So I understand that the line of symmetry is this, and the figure has how many line of symmetry in question C? We are going to write this. We have one line of symmetry. We have one line of symmetry. By the way, this triangle is called a what? This is what? This is an isosceles triangle because these two sides are equal. Understood? Okay. Let's go to another examples. I will give you another examples outside the book just to make sure that you understand. Let's take a lot of figures and figure out if they have line of symmetry or no. What if we have a square like this? How many line of symmetry do we have in a square? First of all, you have the first one that is dividing, similar to the y-axis, that is dividing your square into exactly two equal parts. Okay, this is number one. What about the one which is similar to the x-axis? Again, it's dividing your triangle, your square into two equal halves, one up, one down. What about this one? Yes, again, it's a line of symmetry because this half is exactly equal to this half, right? Till now, we have how many line of symmetry? Till now, we reached 3. What about the fourth one? Yes, again, it's a line of symmetry because this part is equal to this part. So how many line of symmetry you have in a square? We have 4 lines. We have 4 lines. So here I have 4 lines. Right? For a square, we have 4 lines. What if we have a rectangle? I don't want you to see it. What if we have a rectangle? Let's open the whiteboard. What if we have a rectangle? Let's draw a rectangle. Don't bother and don't mind my drawing. Let's try to make it, oh my God. Try to make it a little bit neat and try to imagine that this is a very, very, very good rectangle. Okay, let's try to think about line of symmetries. How many lines? Let's try the ones that we have in a square. Okay, let's try this one, the one exactly in the middle. Is this a line of symmetry? Yes, it is, because these two parts are exactly the same. What about this line? Yes, it is a line of symmetry. It's a line of symmetry, right? We have two, very, very obvious. Just to understand, let me remove these. What about this one? Because this is a tricky one. This is very, very, very important part. Some of you can tell me, yes, teacher, this is the line of symmetry because this part is equal to this part. Actually, it is like each other, but actually it's not. It's not similar. When I tell you, does this figure have a line of symmetry, what do I mean? What do I mean? I mean, can you, if you can fold, if you imagine that this rectangle is on a piece of paper, try to imagine that this piece of paper, that this rectangle is on a piece of paper, and you fold it. You remember the one in the book when we had an isosceles triangle and a line passing in between. If you try to draw this exactly really on a piece of paper and then you fold the triangle on to the line, what will happen to the two parts of the triangle? They will be exactly over each other. The same thing is happening here. Ask yourself, if I have a line passing in here and this is on a piece of paper, can I fold these two parts over each other? Try to do it at home. Try to do it at home and see. If I try to fold these two papers over each other, will it be possible for me? Actually, no, it will not be possible. For the other line, you remember when we drew a line like this? This was a line of symmetry. Try to do this at home and then try to fold your paper across this line. You try to fold your paper onto these two parts and then see, will they be coincided over each other? Yes, they will be, because they are exactly the same, so they will be coincided over each other. But for the other part, for the other line that we drew in here, if we try to do this, actually they will not be folded over each other. But for a square, because in the square, the 4 sides are equal. So if you try to fold them together, they will be folded together and they will be equal. But for here, a rectangle is not all equal. If you try to fold these together, this part will be folded over this part. And is these two sides equal? They are not. So actually this one and this one is not a line of symmetry. So for a rectangle, how many line of symmetries we have? We only have 2. We only have 2. Because actually in a rectangle, how many sides are equal? In a rectangle, how many lines are equal? You only have 2, not line, I mean sides. We only have 2 sides are equal. Okay. Okay, let's go back to the different shapes. Let's see in here. So the rectangle have only two line of symmetries, because if you try to do, as we said, try this with a piece of paper. If you try to fold your figure over this line, actually it will not be folded together. If you did this on your at home, you can make a picture of this and post it, and I will post it on the class story. It will be good. I will try to post actually something like this to understand what I mean exactly with the folding part. Okay, what about in here? For an equilateral triangle, if this was an equilateral triangle, if all of these parts was equal, this is a line of symmetry, and this is a line of symmetry, and this is a line of symmetry. Remember, the first triangle that we talked about was an isosceles triangle, but here this is an equilateral triangle. Since all sides are equal, so all of these are line of symmetry. What about this? This is a line of symmetry. Can you think about any other line? No. In here, if I try to fold this over each other, it will be the same. What about here? Yes, this and this. What about like here? It's only one. If you try to fold these two pieces together, they will be coincided exactly. But if I have another line, they will not. Do we have any other? Yes, example. For a rectangle, we have two. For an isosceles triangle, we have one, as we said. These shapes are very, very important. For a square, how many lines of symmetry? We have four. Exactly, or I can give you an important note. For any figure, most of the figures, if the figure is all the same, if your figure is all the sides of the figure are the same, so actually you will be having the number of line of symmetries equal to the number of sides. And what do I mean? In a square, all sides are equal, right? Yes. How many sides you have? 4. So how many line of symmetries you have? 4. Okay. Regular pentagon. What is a pentagon? Pentagon, girls, by the way, is any object or any figure that have 5 sides. The word penta means 5. The word penta means 5. So I have 1, I have 2, I have 3, I have 4, and I have 5. And since you have the word regular, regular means all sides are equal. So I have 5 sides equal. So how many line of symmetries we have? We don't need even to count. How many? 5 right away. 5 right away. 5 line of symmetry. Regular hexagon. What is a hexa? Hexa means 6. Hexa means 6. So I have how many sides? I have 6 sides. Since I have 6 sides, so how many line of symmetries? We have 6 lines of symmetries. Regular hepta. Hepta means what? Hepta means 7. So I have 7 sides, so I have 7 line of symmetries. Please write this as notes. Penta means 5. Regular means equal, so it's a 5 line of symmetries. Hexa means 6. So I have 6 line of symmetries, or you can even count the sides. And here it's a hepta, so it's a 7. Octa means 8. Octa means 8. So how many line of symmetries? We have 8 line of symmetries. And even if we count the sides, if for example he didn't give you the name, you can count the sides. 1, 2, 3, 4, 5, 6, 7, and 8. We have 8 sides. That's why we have 8 line of symmetries. And for an equilateral triangle, they are all equal and there are 3 sides, so we have 3 lines of symmetry. Okay. Okay, let's go back to our book. We did number C. Okay, going to the second page. In here, question D. Draw the line of symmetries, if any, on each figure and tell the total number of lines. Let's think together. How many line of symmetries we have on each part, on each figure? Let's do it together. For the first one, for the rectangle, we already did it. How many? We have 2, right? And let's draw them together. We will be having a 1 exactly in here, in between. Please, girls, use ruler. Please, you have to use rulers. We have 1 in here and we have 1 in there. So we have how many? Here we have 2. Okay, what about this triangle? Take care, this triangle is nothing. It's nor isosceles nor equilateral. I mean, no side is equal. Nothing is equal. When nothing is equal, can you try to think about any line that if I pass it, it will make two sides of the triangle equal? Nothing is equal. So actually I don't have anything. So actually it's 0. يبقى no lines of symmetry. What about in here? Can you try to think? If I do a line in here, for example, is this a line of symmetry? Yani, is these two parts equal? Of course not. Of course not. But what if I do a line in here, for example? Huh? Is this a line of symmetry? Again, no. Is these two parts folded together? No. This is no. Huh? What do you think? Where? Only there. Exactly in here. Right? Now, these two parts exactly coincided. Yani, again, if you try to fold, if you have a piece of paper and you fold it over this line, these two parts will be exactly over each other. Can you think about any other line? No. So actually this is a 1. So here we have 2, here we have a 0, and here we have a 1. Understood? Okay. Let's go back and complete. Okay. Okay, what do you have to know about any segments and angles in a figure to decide whether the figure has line symmetry? What do I need to know? I need to know that there are at least 2 segments or angles equal to each other. Right? Yani the segments, pairs of segments should have the same length, and pairs of angles must have the same length. So this is what we are going to write here. For number 1, just let me erase all of this. Okay. For reflect question 1, pairs of segments and angles should be the same. You remember the triangle that had nothing equal? It had nothing equal. If you have nothing equal to anything, so can you have a line of symmetry? Of course not. Nothing is equal. And if I have an unregular figure, nothing is equal. Can I have a line of symmetry? Will there be any line that can make the triangle or can make your figure reflect over each other? No. So I should have at least 2 sides equal so that I can have a line of symmetry. Okay. Question 2. If you read question 2, what figure has an infinite number lines of symmetry? Yani, what figure that you can think about that have an infinite number of line of symmetries? What do I mean? Let me draw it for you. What if we have a circle, for example, and you try to draw a line of symmetry? Let me ask you, if we have an exactly line passing in between, is this a line of symmetry? It should be exactly, of course, yeah, it should be exactly. Is this a line of symmetry? So let me do it better. Is this a line of symmetry? Yes, it is. Is this a line of symmetry? Yes, it is. Is this a line of symmetry? Yes, again, because this is exactly equal to this. Yani this part is equal to this part. What about this? What about this line? Again, it's a line of symmetry. So what about this line? We have a lot of lines. What about this line? Any line that's passing by this midpoint will be a line of symmetry. Any line that is passing through this point is a line of symmetry. So actually we have how many lines? I don't have 1, I don't have 2, I don't have 10, I have many, I have infinite number of lines. So actually for a circle is a very, very special case. A circle, this is question 2, by the way, a circle has an infinite number of line of symmetries. because any line you drew that is passing through its center, you know that a circle has a center. If you draw a line passing through the center of the circle, it will divide your circle into 2 equal halves. So I have actually infinite number of lines. Okay? Okay. Going back to our book. Question, we are going to explore two, identifying rotational symmetry. For now, we understood what is a symmetry. What is a line symmetry? Lower reflection symmetry, which is a line that is passing through your object that can divide your object into exactly 2 equal halves. Okay? What about rotational symmetry? Rotational symmetry comes from the word rotation, comes from the rigid motion rotation. Rotational symmetry means, can you try, when I give you a figure, can you try to think about a rotational movement that if you do it to your figure, it will make your figure the same? What do I mean? Can you see this star in here? You remember that the ceiling fan? And you remember the center point of the rotation, the center of rotation? Let's say that the center of rotation was exactly in the middle of my star. So my star will be moving like this, will be moving and rotating around the center of rotation. Do you think that if I start moving my star at some point, at some angle of rotation, it's rotating at some angle of rotation, the figure will be the same? I think so, right? Let's try to see an animated thing for this. Okay, let's see this, for example. Can you see this star or ceiling or fan or whatever, this shape? Does it have a rotational symmetry? If we consider, for example, that this is going to be moving across this point, and this is the point of rotation. Let's see how he is going to rotate it. Now, if we stopped in here, if we stopped exactly in here, we rotated it with a certain degree. Is the two figures the same? Yani I rotated it with this degree. Is the figure the same or the figure change? Yani the image and the pre-image are the same? No, they are not. The first image was this, and then suddenly I became standing in here. Is my figure the same? No. Now let's complete rotating. Huh. What do you think? What happened? What do you think? My figure or my image is exactly like the pre-image. My figure, my image is exactly like the pre-image. But I started in here, and then I started rotating. We were rotating, rotating. Exactly in here, what happened? My figure is exactly the same. So do I have a rotational symmetry? Yes, you have a rotational symmetry for your figure. So a rotational symmetry is when I have an object that can rotate to give you the same figure. Yani girls, let me give you a very quick example, just to make sure that we understand the rotational symmetry. Just bear with me. I will open one example from the previous lesson, the rotation image. Yes, in here, this figure rotated to become in here. So when I ask you, is this kind of rotation is called a rotational symmetry? No. You rotated, but did your object land to be the same? It didn't. So does this object have a rotational symmetry? No. Oh, this is what I'm calling, this is what I'm talking about in the rotational symmetry. Rotational symmetry means that when you have an object that you can rotate it with a certain degree to give you the same object. Here he will start rotating, he will start rotating. Each time he rotates, he can get the angle, right? Oh, this is called the rotational symmetry. So going to our book. Here he is writing angle of rotational symmetry is 72. Oh my God, how did you get the 72? I will tell you a very, very, very easy trick. Whenever you have an object, most of the time for an object, girls, to have a rotational symmetry, it should have all sides equal. Yani for an object to have a rotational symmetry, all parts of the body should be equal. Yani like in here. For example, if this star was not a regular star, as you can see, it's a regular, and this part is the same as this, as the same as this, as this, as this. All parts are actually the same. They are similar. What if this star was not regular? If this star, for example, in here, this part was larger than the others. So will they have a rotational symmetry? Actually, no. Because when it rotates, the part that started large in here will be large in here. And then it will be large there, and then it will be large here, and suddenly, is it rotational symmetry? No. But for a rotational symmetry to happen, all parts should be equal. So first of all, when I give you an example, you have to go investigate your figure. Is it all equal? Yes, it's all equal. So actually, it will have a rotational symmetry. How can I get the angle? To find the angle, what are you going to do? You know that for a complete circle to happen, to give, yeah, for a figure, to make a complete rotation and go back to its place. This is how many degrees? It's a 360 degree. It's a 360 degree. We know that a complete circle, any figure, to make a complete circle, this is actually how many degree? This is a 360 degree, right? So for you to find the angle, always you are going to do what? Looking back to our object here, the star. Ask yourself, how many parts we have in a star? I have 1, I have 2, I have 3, I have 4, and I have 5. We have 5, right? So what are you going to do is just very, very easily. Let me remove this. You are going to divide 360 by 5. And then you will see the answer. Let's open the calculators. Let's do 360 divide 5. The answer is 72. So my rotational symmetry is starting at 72. So my angle is 72. So if I rotate my star by 72 degrees each time, what will happen? My star will remain as it is. So if I rotate it 72 degrees, and then 72, and then 72, and then 72, and then 72, each 72 will make the figure as it is. What if we have an equilateral triangle? Equilateral. Why equilateral? Because all sides are equal. If they are not equal, do they have rotational symmetry? No. So since this is an equilateral, it have a rotational symmetry. A rotational symmetry. To find the degree, by how many degrees did you rotate the figure? By how many degrees? Huh? How many angles? How many sides we have in our triangle? I have 1, I have 2, I have 3. So I'm going to divide 360 as we did before. Just I'm going to divide 300. Just wait. Yes, let's do it together. In here, what I'm going to do is that let's divide 360 divide what? 3, because we have how many angles or how many sides? 3. The answer will be 120. So only 120? Actually, no. Actually, no. What do I mean actually, no? In the previous example, in the star example, I told you 72, then 72, then 72, then 72. يعني as if each time you are adding a 72. يعني I can say in here that my angles of rotation will be 120. And then I will add another 120. So it will be like 120. Multiply 2, so it will be a 240. يبقى this is another angle. يبقى if I rotate my figure by 120, the triangle will be the same. This is the first time. The first 120. The first 120, guys, this vertex will be in here. And then if I rotate it by 240, يعني which mean from here I moved 240, يبقى this vertex will be in there. It will be the same figure. And then the last one, which is 240 plus 120, which will become a 360, يبقى it will land in here. Each time he will ask you about the angles of rotation. The first thing you have to do to investigate, does this figure have all sides equal? Yes, it have. Since it have, يبقى it will have a rotational symmetry. To find the angle, you are going to divide 360 by how many sides? It's 120. And then to find all angles of rotation, you are going to take your first number and then multiply it by 2, multiply it by 3, multiply it by 4 until you reach 360 degrees. يبقى in the previous example, in the example of the star, if we try to get all the angles of the star, let's get all the angles of the star. 72, right? 72. So I'm going to start multiplying 72 by 3, by 4, by 5, until I reach 360. يعني actually it will be, let's try it with the calculators. 72 multiply 2, it's a 144 degree. And then 72 multiply 3, it's a 216. And then 72 multiply 4, 288. And then 72 multiply 5, 360. يبقى الangles are all angles till 360. Okay, going to the next page. Okay, girls, in here, question B. Determine whether this figure has rotational symmetry and identify all the angles. Does this have rotational symmetry? I will ask myself, does this figure, all sides of this figure are equal? Yes, they are equal. Since they are equal, so it have a rotational symmetry. If I'm going to write yes. What about the rotational? How can I find the angles? How can I am I going to find the angles? How many sides we have? We have 4, right? So we are going to divide 360 by 4. It's equal to 90. So my angles will be 90, and then 90 multiply 2, which is 180. And then 90 multiply 3, which is 270. And then what comes after 270 exactly? The 360. You don't need to write the 360. So I have how many angles? 3 angles of rotational symmetry. I have 90, I have 180, and I have 270. This is for question D. Okay, okay, let's go back to our book. The other shape. For the other shape. Does this side or does this figure have any equal sides? It doesn't. It doesn't, right? So do we have a rotational symmetry? We don't have a rotational symmetry. Just right away. We don't have a rotational symmetry. So just you are going to write a no. Okay? Okay. What about the other figure? What about the other figure? This figure. What about this figure? Can you think about any rotation that we can do it, that will make the figure the same? For example, if we do a 90-degree, what will happen to your figure? It will be standing in here. Is it the same? No. What about 180? If I did a rotation of 180, what will happen is that it will be just upside down, and this will come here and this will be there. But the figure will be the same or not? It will be the same. It will be the same. So actually, yes, this have a rotational symmetry and the angle is 180 degree. Do we have any other angle? No. Okay. Okay, describing symmetries, the last part. What is this? Just for each figure he will give you, you are required to just tell him for each figure, does this figure have a rotational symmetry or a line symmetry? Yani, as if we are just putting the two parts together. Describe the symmetry of each figure, draw the lines of symmetry, name the angles of rotation or both if the figure has both. Let's do question A together. First of all, does this line have line symmetry? Yes, it have. It have two equal parts. What if I draw a line in here? In here, exactly in here. Will they fold together? They will be exactly two equal halves, like in here. This part will be exactly like this part. What about the line symmetry in between? Again, the upper part will be exactly like the lower part. Okay, what else is a line of symmetry? What else is a line of symmetry? These two lines are line of symmetry because these two parts are exactly the same as well. So 1, 2, 3, and 4. So I have how many lines of symmetry? We have 4 lines of symmetry. What about the angles? We have 4 angles. So you are going to divide 360 by 4. It will give you a 90. And then to find it, I'm going to get the multiples of 90. So it's going to be 90, the first one, and then 180, which is 90 multiplied 2, and then 270, which is 90 multiplied 3, and then comes the 360. You don't need to write the 360. Okay? Okay. You are going to try to do question B by yourself. Try to do it, please. And in here, I'm going to do question 8 with you because I think it might you might be confused with number 8. For number 8, it is the same. Just tell him, does it have a line symmetry, and just tell him the angles of rotation. First of all, does this have a line of symmetry? A line symmetry, does this have a line symmetry? Actually, it doesn't. I will tell you why. First of all, you think it might be equal. It can be, but if we don't have these small parts in here, this residuals part, yani if this was a regular figure without these small parts sticking outside the figure, it might be equal. Yani it might have a line symmetry. The problem is, if you try to put a line in here and you try to fold these two parts together, you will find this residual small part sticking outside going up, and in here it's going down. So they fold together? They will not fold together. That's why this is a very, very tricky object. If we didn't have these residual small parts sticking outside my figure and it was a normal figure, you know how many line of symmetries we will have? Didn't we say I have this equal to this, equal to this, equal to this, equal to this, so I should have a 5 line of symmetries? This is yes, but if we didn't have this very, very small part, lower PQ and the RS and the KJ and the LM and the N thingy, the part in here. If we didn't have these parts, this will have a line symmetry. But since we have these strange parts, each one's going to a different direction, so actually nothing will be similar to each other. So this is not a line symmetry. But is it a rotational symmetry? Yes, it's a rotational symmetry. If we start rotating it, it will give you the same figure. How many? what is my angles? How many angles we have? I have 1, I have 2, I have 3, I have 4, I have 5. So it's going to be what? It's going to be 360 divide 5. 360 divide 5. And then to find the angles of rotation, let me show you the answers. In here, just this one. I don't want you to see any other one. Yes, let me open it for you. Okay, in here. So it is a rotational symmetry. Number of lines of symmetry is nada, nothing, 0. What about the angles? 360 divide 5 gave me 72. And then 72 multiply 2, 144. 72 multiply 3, 216. 72 multiply 3, 288. And then 72 multiply, so this is 2, 3, 4. So multiply 5 will give you a 360. 360 is not needed to be written. You can write it or no, whatever you want. Okay, thank you very, very much. On Class Dojo post, inshallah, I will tell you exactly the performance indicator for today, and please send me pictures of all your work. Thank you.